Hey, Dr. Dan here. We are going to be implementing a state machine AI in Unity, state machine based AI in Unity today. So, first thing we're going to do is take full advantage of Unity's standard packages for characters. Now, we don't need to do this. But it's going to give us more realistic effects on the AI, and it'll just be more fun. But everything we're doing could be done with just custom character controllers. So I'm going to import the characters package into a brand new Unity project. And let's see, what do we need here? We don't need first person. We're going to make this third person. We don't need a roller ball. I'll take the third person character. I suppose we could take cross-platform input. That doesn't really matter. Alright. And utility. Sure, why not? Okay. So in just a second, we will get our the characters that we're going to put our state machine scripts on. I will pause. Okay, cool. So here are the standard assets we've got. Let's let's make some ground here. So I'm gonna just make an empty cube. I'm gonna set the transforms to like 40 by 40. Let's save this scene as basic state machine AI. Okay, and then let's check out our prefabs. So in characters, third person characters, let me pull this over a bit. We are going to use both of these prefabs. So one is a AI third-person controller, and another is third-person character. And it looks like they set themselves up nicely with the appropriate level of distance, which is cool, to the ground. So let's take a look at these prefabs. And actually, for now, let's just run it and see what kind of errors we get. Alright, so get remaining distance, agent, right. So the first error we're getting is that we have an AI in here, the third person AI. So let me just delete that and let's test, let me delete that and let's test our third person controller. Make sure we're not getting any errors. Alright, so we can move around, cool. So I'll zoom out a bit so we can see. All right, the first thing I want to do, because I don't really like not being able to see where I'm moving, is let's set our camera up to follow this person around. So to do that, we are going to take a look at this script that we have. So now that we have this imported, these scripts are ours to modify as we want. Just make sure you don't re-import because it'll override any changes we make to the scripts that are attached. These are just normal scripts that we've imported along with Unity. So let's see, this third person character is the controller we want to modify to get a camera following it around. So if we scroll down, you'll see we have somewhere in here a camera. Perhaps it's not in third person character. Let's see here. What about third person user controller? Let's see what that is. There we go. Okay, so we have a reference to the camera, to the main camera here. And we have a reference to the components. So now the question is, why isn't the camera moving it around with the character? So in fixed update, which is where movement's going to happen, we have if direction to pass the character. If your camera is not null, so if there's a main camera, we are going to move the camera forward by mcam forward normalized. Okay. So what that's doing right there is using the camera to calculate the direction to move in. But we can also add a line of code here where we just adjust the camera's position. So I'm going to do if mcam dot position, and I'll set that equal to a new vector 3, and we can use the transform dot position transform. So we'll use the transform of the character itself, its x value, and then transform dot position dot y, and we can add maybe like a variable called ycam scaling. We'll set that up in a second. And then transform dot position dot z plus z cam scaling. Okay, and that's all we'll do right there to get this camera moving around. So now we need to make these floats. So let's make them up at the top. Make some public variables here. Public float. What did I call it? Ycam scaling equals, set the default value to 5. Public float zcam scaling, and we'll make that one -5. The reason is we want to go up and then back from the character, so we can kind of see where the character is and still use the camera as it's being used here to calculate camera relative directions to move. So wherever the camera is, we'll be moving the player using that camera, or world relative vectors if there isn't a camera. All right, so let's save that. And that by the way, this third-person character controller is getting our input from cross-platform input manager. This is one of the utilities things we imported. You know, you could use just input.getAccess, but let's leave it as it is, since we did import those utilities functions. Okay, so back in Unity, if we hit play, now when we move around, you can see the camera is moving. You can't really see the player yet, so perhaps we can fix that with a simple rotation on the main camera. So if we rotate, let's see, we want to rotate down the X axis, I believe. Maybe like 20? Let's try 30. That looks more reasonable. Okay. So you see the camera is actually set up here, and as soon as we start running the code, it's just gonna, there, that looks fine to me. It's just gonna find the character and adjust the position. So you can see it moving around right there. Cool, okay, we've got that set up. So now let's start tinkering with our, let's call this ground. Let's start tinkering with our AI third person. All right, so we have this AI third person, and in many ways it's very similar to the third person character controller, except its navigation. Let's take a look at these scripts. So it is a NavMesh Agent, and what it'll do is it'll set up its NavMesh, and we actually need to set one of those up in our scene as well. And then it'll get the same third-person character that we have here, so all the things available to us that we have in the third-person character controller, we have in third-person character. So things like jump, speed, move speed, all of these we can set, whether the character is grounded, references to the animator, to the rigid body, to the capsule collider, and a nice move script that we'll be using. Alright, so we're going to kind of stack our AI on top of this. All of this animator function, update animator, would take us too far afield from designing a state machine, so we're just going to use the one that we get for free with Unity. So, alright, back in Unity, let's go ahead and bake a NavMesh. So I'm going to switch over to navigation in my inspector. If you can't see that, go to Window, and then Navigation, which is here, and it'll pop up. And I'm just going to bake the ground, so we have a NavMesh. Not seeing it. Oh, there we go. Bake. Okay, so right, so that's not working because our ground does not yet have a rigid body. So I'm going to select ground, select inspector, add component, rigid body, and let's go ahead and uncheck gravity, or the ground will fall beneath us. And now we should be able to bake a NavMesh. So select navigation, bake. Still not seeing it. Perhaps one more thing on the ground in the inspector. We want to make sure that it's static. So if we check that now, and let's try this one more time. There we go. Alright, so now we have a NavMesh. Let's make like an empty game object for navigation points, so we can get like a patrol behavior going. So we'll have two state behaviors at first, one which will be patrol and the other which will be chase, and we can just add to them as much as we need. For patrol, we'll want to be moving between nav points that we've set up. So let me just create a cube in here, and I'll switch to my inspector. So I just have a cube. I'll call this Nav Point. And I'm going to reset that transform, and I'll reset the transform of the Nav Point empty game object. And now I'll drag Nav Point into Nav Points. Alright, and let's put it over here. Let's set the Y to 1 and save. So the way that we're going to grab all the nav points that we have is we'll add a tag called nav point and save it. Alright, there's lots of ways to do this with a mesh agent, but this one seems to me to be simplest. So we have, let's make sure we add that tag to there, and then we can save. Alright, so now in our AI character controller, we can give this a target, which is this nav point, and just test out that it walks to that nav point. Okay. Oh, we forgot to turn off the gravity. I thought we did that. We're not using gravity. Oh, you know what? We still need to check is kinematic on our ground, or it's going to fall like that. Alright. And it's falling just because of its reaction to the player's movement, not due to gravity. But all right, so he's running towards the cube. That's our nav point, and he's just going to keep on trying to get to it. So let's tinker with his stopping distance. So if you scroll down, a NavMesh agent has a public property called stopping distance, which is set to 0.2. Let's set that to 1. We have a box with that is 1 by 1 by 1, so that should be fine. Now, if he should stop as he gets to the box. Yep. Okay. Cool. And that we can always set dynamically in our state machine when we have that set up. So now, what's next? Okay, so let's make some more nav points so that our patrol script has something to move between. So I'm just going to Control D, or it could be Command D if you're on a Mac, to duplicate these a couple times, move them around a bit. They're all tagged as nav points, and now I'm going to save. All right. So the first script we're going to add, so a state machine, just a little bit of background, is going to be a machine that handles our states. In fact, I can probably show you in the animator what it looks like. So visually, a state machine looks a lot like this, and you could actually use the animator in one big monster class with all the functions that you want and all the transition to handle it. But a state machine looks like this, where you have like different states. Like for us, we're going to have patrolling, chasing, right, and then whatever else we want to add. And when something happens, we move from state to state to state. So when I'm patrolling and I see someone, I move to chasing. When I can't see them anymore, I move back to patrolling. That's the kind of thing we're going for. We want a general state machine, though, that we can attach, that we can add states to as much as we want, and that also has access to the animator. So we'll start by making a script called state. And we're going to make this abstract. So, to make this abstract, first of all, we don't want to inherit from mono behavior. We just want a normal abstract class. What abstract means in object-oriented programming in C# is that this class has to be implemented, right? That you can think of it as like a blueprint for a particular class. So we'll have a blueprint, which is our abstract class state, and then we'll have particular states which inherit from state and implement it. So patrol state, chase state, they'll all inherit from state. They'll be children of the state class. So we want all of those children classes that we're going to implement to have a reference to something I'm going to call a state controller. And this isn't a thing yet. This is a script that we're about to write. But the state controller is going to have all the information about the individual AI. So because we might have more than one AI, and they might be in different states, we don't want the states themselves to determine what the AI is doing. We want the state controller that's attached to those AIs to take the information of the AI into the state and then use the state. All right, so that's the kind of that's the reasoning behind having that reference to a state controller. So we'll have a public abstract void, a method called act, which again is abstract, so we'll have to implement it in every state class that we make. Public abstract void check transitions. So before we act in in classes like patrol, we want to know, should we still be patrolling or should we be chasing someone? Or like before we chase someone, we want to know, should we be going and healing or should we go ahead and perform the actions? So we might even move this up just to keep things in logical order. So we'll always check, should we make a transition? And if we shouldn't, then we'll go ahead and act. If we should, we'll make the transition and then we'll act. All right. We'll have a method called onStateEnter, and that's for just a handy little method to have to override so that we know like what state we're in, so we can handle things like the color of the agent is what we'll use that for, but you could use it for all kinds of things. And we'll have an onStateExit, so you might want to like reset the transform or something on StateExit. We'll have a method for that that will override if we need it, right? So that's why we're doing public virtual void. Sometimes we don't need these, and so we won't require that they be implemented. All right, and then our constructor is going to take in the state controller, which will contain any method that every AI needs to have, like getting the range of an enemy or finding a location to go to. Those are methods that all agents need to have, and they probably need to have them in multiple states. So we'll put those methods in state controller. And we'll also put things like its current position, its health, its things like that. Okay. So when we do that, so we'll always pass in the state controller and set that equal to state controller so we have a reference to it. All right, cool. So now we need to write the state controller class. All right, so let's write that class. Yeah, so it's throwing an error and saying, hey, you don't have a state controller script yet. So let's go ahead and write it. State controller, and open it up. All right, first thing we're going to need is a whole lot of variables. So we'll need a reference to the current, just state, state controller, yeah. We'll need a reference to the state, current state, and I'm not sure why it's not seeing state. That's interesting though. Huh. Should recognize state as a class that we can access. All right, let's press on. It's just a problem with the editor. Maybe it needs to spin or something. Game object, public game object. Oh man, I'm having a lot of trouble with my editor actually. Look, even mono behavior isn't getting referenced. Let's close that and reopen it. I'm not sure what's going on here. Okay, I'm going to actually, because I really don't like it when my editor doesn't autocomplete, I'm just going to shut down Visual Studio and I'll pause the video. I'm just going to restart Unity. Okay, let's reopen state controller. I think it was really just a problem with, it was just a problem with Unity and its connection to Visual Studio behind the scenes. So, okay, now it's it's recognizing state as a script. That is good. We need a reference to our current state, let's see, we need an array, a game object array of our nav points. We need an int, which is our nav point number. So what nav point are we currently on, so that we know to go to a new one. We need a we might need a float for remaining distance. We might not, and I'm thinking like we might need to track how close we are to these nav points, or we might let the the NavMesh agent handle that. Either way, we might want to debug log out our remaining distance is my thought here. Alright, we're going to need a public vector 3 for our destination. So once we have our nav point, we can start moving towards it. And we're going to need a reference to the AI. So we can get that by, first of all, let's add Unity. Well, we don't even need that really. We can just say, hey, Unity standard assets dot characters dot third person dot AI control character controller AI. The reason I'm not using the AI from the Unity engine is we won't really need to do that. We could import that, but we'll let this third-person AI character control script handle any AI functions like approach, blah, blah, blah that we need. Let's grab the colors, the renderers and the materials. So, because I want to change the color of this AI as we enter different states so we can visually see it happening. So I'm going to have a renderer array, children rend, and then on state enter we'll override that so that we go through these and modify the color of the agent. And that's it for now. Alright, so we're going to need a method for getting our next nav point. So we have these nav points. Well, first of all, we don't have these nav points. Let's go grab them. So let's see, we need to in start say nav points equals get component. Nope. Game object dot find objects with tag, and we're looking for a nav point. So we'll get a reference to those. Let's see, what else do we need to do in start? Oh, we need to set this public variable up so we can say AI equals get component, and that's going to be in Unity standard assets dot characters dot third person dot AI character control. Okay. We'll get a reference to the AI character controller script, which is this one. And that's because this has a nice handy set target and then an update that moves towards the target. And it does it by, so we're moving towards the target by using our NavMesh agent, right? So our AI script, which is just a short little script, is calling our NavMesh agent script, and in that way we're moving the way we need to move. And we're actually checking whether we're within the stopping distance here to an update. So as soon as we set a target in like a patrol or a chase script, the update in our AI character controller will take care of us moving towards that target until a certain range. All right. So now that we have the nav points, we're going to need a method for grabbing the next nav point. So public vector 3 get next nav point, and inside this method we will set our nav point number equal to our nav point itself, right? Plus 1, so we're getting the next one, right? And what happens when we go over the amount of nav points we have? Say that I want to add 20 nav points, but I don't want to have to go into the script and change this method. We'll just do a mod nav points dot length. So however many nav points we find with this get all the things that are tagged nav points, we have the length of that, and we're modulus we're using a modulus operator, modulus operator to ensure that when we go over, we start again at the very first point. So if there's 3 in there and I get to 3, the next time I add 1, it'll start me at 0. Right? So that's how we'll get the number there, and then we'll just return the nav points at that index. But we want to return the transform.position, because if you'll notice in AI character controller, oh, it's actually setting it by transform target. That might be okay. Let's leave it at position for now. We could set this to transform. I think that'll be fine though. Alright, let's handle the color change. That one's pretty easy. Public void change color. This is a cool script to just have, you know, in your head. We pass in a color and we're going to change the game object of interest to that color by changing all the renderers. So for each renderer R in our children array of renderers. Oh, and did we get a reference to that? We did not. Okay. We probably should do that. So let's, yeah. So here in start, we need a reference to a renderer. So let's set children rend equal to get components. Components in children. Render. Get components in children. Render. Boom. Oh, and the other thing we'll want to do is set this initial state. Let's make that a to-do so we don't forget. Alright, we don't have a function to set the state yet, though, so let's leave that for now. Actually, we don't. You know what? Yeah, we should write that function. So once we have all the children renderer, all the renderers, which are just things that handle like the visual aspects, the materials that we see visually on the screen. Now we can go through them all, and we can say hey, for each material inside of those renderers, because each renderer has a R. Should have picked a different letter. R dot materials. Each renderer has an array of materials. Let's set the color of those materials in the renderer to the color we pass into this method. Okay, so we'll do that just to keep track of what state we're in visually. So if I'm in patrol state, I'll set it to like blue or something. Okay. So now let's write our move to destination. So, oh, so yeah, we're not writing our own move to dist. We're gonna override the. Okay, now let's handle update. So there's two things that are gonna happen in update. We're gonna say, hey, current state, check your transitions. Do we need to move to another state? And if we don't, go ahead and act. We'll do that every frame. Every update, I mean. Which happens multiple times a frame. Once per frame, yeah, so every frame. Update is called once per frame. Alright. So we need a way of setting our states is the next thing to do. We can make this a public void set state. We'll need to be able to set the state from another state. So that's why that has to be public. We'll pass in a state to that method, and we'll say if our current state does not equal null, call our onExit in case there's something we need to do. and then we'll set current state equals state. And we can, if we wanted, set the game object name to something like AI agent in state plus state.get type name if we wanted. Another way of tracking what state we're in. Probably don't need that actually, but what the heck. And then finally, if our state is still not null, we will call current state dot on state enter. So once the state's assigned, we'll call its onEnter method, and as we're leaving the state before we assign the new state, we'll call the exit method. And I believe that is all we need to do there. Alright, so now we're going to save that, switch over to Unity, and let's make our patrol state. Patrol state. Alright, and in our patrol state, we need a vector3 destination. We need a public patrol state. We need a constructor, right? Which will take our state controller the way we set it up. State, and we'll call that state controller. That's fine. And we will pass in the state controller to set that up. All right. And then what did I do wrong there? Public patrol state. Interesting. Okay. I'm not sure why that didn't work, but oh, I know why. Because patrol state doesn't yet inherit from state. So this is a state object, a state child of state. Doesn't implement the methods, that's fine, we're about to do that. So we need a couple methods. We don't need start or override, or update, I mean. We need public override void check transitions, and we can get rid of that. Let's just leave that blank for now. So right now we don't have any transitions. That's when we're going to move to other states. But we can do public override void act here. And what we want to do for act is if our destination does not equal null, if our destination does equal null, right? So if we don't have a destination, or we've reached our destination, which we can get by state controller, oops, lowercase state controller. Why is it not letting me do lowercase? There we go. Dot AI dot dest. Interesting. doesn't like the way that I've implemented this. I'm just going to get rid of that. And instead, I'm going to say, okay, so I've rewritten this a bit. I think I see what the problem is, though. We can leave the short form of this constructor here. In state controller, we, in state, the base class of this, we've forgotten our state controller. Okay. So now in control state, now I should be able to call methods of state controller. There we go. All right, so state controller.ai destination reached. AI dest. Is there no destination reached? Let's switch back to state controller. All right. AI equals get component, third person, AI character controller. Let's look at our AI character controller. We need to write a method here that tells us if this is true. So let's cut this out. Let's say if destination reached, and then public bool destination reached, return that. Okay, so what we're doing here is an update. We set a destination. If the destination's not reached, right, then we want to move. So we actually need to say, hey, is the agent's remaining distance less than the stopping distance? Right, so have they breached, have they come close enough that they've passed through whatever that minimum requirement of stopping distance is? And if so, we'll say their destination's reached, and we won't move anymore. If their destination isn't reached, so this is all doing the same thing, but we can also have access to whether their destination's reached from other scripts now, because we wrote it in a method that returns a bool. So I just modified the AI character controller a bit there. Now in patrol state, I can use that method. All right, so if the destination's reached or the destination's null, we are going to set the destination to our state controller get next nav point, and then in our state controller AI we can set our target to our destination. That's kind of interesting. So we do need a transform here. And I see why yeah, okay, so back in state controller, we can just return the transform here, and we can make this a public transform. We can make our destination transform in our state controller. Anything else? That's fine. Alright, so now in patrol state, we'll make our destination a transform as well. And here we're setting it to the next nav point. We set to the destination. Cool, okay. Finally, let's write a public override void on state enter, and we'll set the color here. So we'll say oh, you know what? as we enter this state, we should probably go ahead and get the first nav point. So state controller, get next nav point. Should be the first thing we do. And then let's change our color to blue. Okay. All right, and that's it. So now back in Unity, we have this AI. Let's go ahead and add only the character controller. Not the, I mean the state controller. All right, this is state controller. We'll go find the nav points. Remaining distance we wound up not using. Let's just go ahead and get rid of that. State controller does not. Ah, we misspelled it multiple places. Okay, make sure you don't have spelling errors. Alright, so now we save that. And our AI has this. Okay, a destination. And we actually don't need to see that. So let's change our reference there. Oh, but you know what? It does need to be public because we need other things to see. Okay. So let's hit play. And we go to, all right, we're getting a null reference. Right. Because we haven't set the initial state. That to do, remember? All right, so let's go ahead and do that. So in our state machine, state controller, let's set the first state. So current state equal, actually, how do we want to do this? Should we use set state, I'm thinking, or should we just directly set it? Let's set it this way. So set state, because we'll want a new, we'll want a new state, new patrol state, and then we'll pass in the state controller itself. All right, that should be good. So now we should turn blue and start patrolling. There we go. Wonderful. That is our first state. Okay, so now the process of adding states is pretty easy. All we need to do for every state it's gonna be the same kind of process. So we need to think first about a transition from patrol state. What is going to be the condition that will tell us to transition? So let's say that in patrol state we need to let's write a to-do here. We need to check if player is in range. If so, switch to attack or chase. Okay, so we'll want to check if the player is in range probably in a lot of different states. So this seems to me like a method that we would want in state controller. So let's just write one. Let's call it check. Let's see. Check. Yeah, if in range. And this will be a public bool, right? If it's in range, we want to know. And check if, how about player in range? So I have a good name for that. All right. So we're going to need Actually, we might want this to be a more general function. How about we do this? Check if in range, and we pass in a string, which is the tag. Yeah? Alright. And then what we'll do is we'll try to get all the components. So we'll say game object array ranged or enemies equals actually we'll declare this up here. We can keep an eye on it. Only declare it once. Alright. So when we check if something's in range, what we want to do is say enemies equals get game object dot find find objects with tag, and the tag will be tag. Oh, we'll just pass in tag, I mean. And then if enemies does not equal null, we'll do something. We will say for each game object g in enemies, if we'll use a vector3 distance formula here. So if the distance between, that's what vector3.distance calculates, the g.transform.position and the transform.position of this particular game object that the state controller script's attached to. If it's less than, now we need a variable for range, public float detection range. If it's less than detection range, and let's set detection range to like 5 by default. So if that happens, let's keep a handle on that object that we find. So let's have a public game object enemy to chase. So we'll set enemy to chase equal to g, so that throughout any state we can know what enemy we're chasing. We'll set enemy and we'll return true. So that's after we scroll through all of those. If nothing happens, we will by default return false. Alright, so that's going to be our function there. Back in patrol state, now we can say something like if we can say something like if state controller dot check if in range. So if we get a true return on that, then and we need to pass in a tag. Let's for now just use the tag player. I think that has to be a capital P too. Then we're going to state controller dot set state, and we'll make it a new state called chase state. And we'll pass state controller into that chase state. All right, we don't have a script for that yet. so let's comment this out, and let's just put a debug line in, debug.log, player detected. Okay. And then back in Unity, let's test this out. So first, we need this third person controller we can tag as player. Apply that. Let's apply that. And hit play. So immediately we get a player detected. Cool. Okay. So now let's write a new state called chase state. And chase state's going to inherit from state. And I am just going to go, let's see, did we even wind up using destination? I guess we did. Okay, so in chase state, we're gonna need, that's its problem. Oh, we don't have a constructor yet. All right, I want to do public chase state controller state controller. Just to show you a different way of doing this that's a little less confusing, we can say base.state controller equals there. What's wrong with this? State inherits from state. Chase state. Did I spell something wrong again? Okay, let's do it the same way we have here. So I'm just going to copy that over. I was going to try and show what I thought was a less confusing way, but that's okay. Alright, chase state. There we go. Save that, and it's still mad because we don't have some methods, so we're going to need methods for public override. Void check transitions, and we'll need a method for public override void act, and we'll have a public override void on state enter. Okay, so on state enter we can do first. Let's set the color. State controller dot change color, and of course we'll set it to red. The other thing I want to do is let's do state controller dot AI dot agent dot speed. So we can just modify the speed to like half of what it is by setting it to 0.5. That's just so that we can like outpace the enemy, so that we can see it switch back into its patrol state as soon as we're out of view. So just like I indicated, we will need to check if our enemy to chase, if we're not in range anymore. So if not state, so if we slip out of range, check if in range, and we put in our player tag, then we'll switch back to our patrol state. So we'll do state controller dot set state, new patrol state controller. All right, so that's how we'll switch back. As soon as we outpace the enemy, we'll be fine. Otherwise, let's just check if our state controller dot enemy to chase. Let's make sure we have a value for that. So we got through that loop and somehow assigned a value to our enemy to chase. And if that's so, we can set our destination equal to state controller dot enemy to chase dot enemy to chase dot transform. Yeah. And then we will just state controller dot AI that will set our target to this destination. Could be done in one line of code, but it just seems more readable to me that way. Okay. That's our on-state enter. That's our transitions we're checking. And we should be good to go. All right. So I'm going to save this. And now back in Unity. If we play, we're blue. All right, something's not right because we're definitely within the detection radius. We got a player detected, but we're still in our patrol state. So let's see what's going on. All right, so in patrol state, did we actually? No, we did not. We commented that out. Okay, so we want a state controller, set state, new chase state, and we pass our own state controller in. So now it should work. Here we go. Yep, it sees us. It's moving slower now. If I get out of range, it is moving back. It's transitioning. That's kind of interesting. Transitioning to patrol state. It's in patrol state, as you can see, but its target is not getting updated, and neither is its speed. So let's see what's going on there. And well, that'll be things in on-state enter. So our destination equals state controller dot get next nav point, and then our act. We're only setting the target in act, so we can set the first target down here in our destination, or our destination's reached. So it never actually gets reached. So we'll set the first destination right there in code, and then when that gets reached, this will be satisfied and it'll run through the act code normally. This is why the on-state enter functions are useful. Okay, that should be good then. Switch back to Unity and hit play. Alright, I am seen by the AI. If I run out of view, you'll see that the AI is now moving between the nav points. If I run back in view, it'll see me. The other thing is, look how it's walking now. We only wanted walking when we were running in chase state, which isn't very realistic because you'd want chase to be running faster, but we can change that real quick. So the code where we set the speed was down here. Let's just grab that, and an on-state enter in patrol state. Let's make sure that the speed is set to 1. Alright. Kind of reverse realism, like realistically in a game you would want, or life, you would want to see you would think that someone would be chasing you faster than they're patrolling. We switched it so that we can outpace the enemy and just show the state machine in action. Alright, so he's in his patrol state. We're getting a null reference. We'll have to see what that's going on there. Okay. Not sure why that's getting a null reference, but on state enter. So it seems like we might be getting into patrol state before we need to. Didn't break the game. That's good. Let's see if we only get one of those errors the first time we enter patrol state. Run it again, see if we get that same error. Yep, okay. So, a couple of ways to handle this real quick. On state enter gets called in from start of the state controller when we set a state. So it might not have this yet. So I guess in patrol state, let's just make sure we have it. This is not great coding, but whatever. State controller.ai.agent speed not equal no, and then we'll do that, but we'll still set the target and the destination. Actually, speed is not the thing. Probably agent is the thing we want to make sure isn't null. The NavMesh agent may not be set up yet. Alright, let's make sure that error goes away. Cool. Okay. And that is basic state machines. So you can see the process of adding them is fairly easy at this point. They're all independent code. You can transition on different conditions to different states. So if this if I wanted to check if my health was low, then maybe go flee. I could put that first, right? And have a new state called go flee and regenerate or something like that. And we'll show how to do some new states eventually, but for now I just wanted to get you started so you could add your own states. You could see how you could and you can see how you can easily apply this to any kind. You don't have to use these third-person character controllers. The only things we're really using in this is the character.move, and you could just use a rigid body movement, any kind of movement vector where you're checking is the destination reached will work for the scripts we've been talking about. So the state machine is independent of these assets that we use to illustrate them. Anyway, that's it. Thank you for watching. See you next time.